we're asked to find the height of the water level in the container. So notice that we're not trying to find the height of the container, just how much of it, the height of the part of it that's filled up with water. One thing we know is that there's 2.5 liters of water in here, which is the capacity, but we actually would like to be thinking about that in terms of volume, because with volume we can then work backwards and find the height. So there are 1,000 cubic centimeters in each liter of water. And so that tells me that that 2.5 liters will be 2,500 cubic centimeters. So the formula for volume, this is a rectangular prism, and in fact the water itself forms a rectangular prism within the container it's in. So the formula for volume is length times width times height. And what we know is that our volume is 2,500 cubic centimeters. We also know the length, we also know the width. So 25 times 15. And what we're looking for is the height. So we'll leave that as a variable. To begin this problem, I'm going to multiply 25 times 15, and that gives me 375 multiplied still by the variable h. To solve this, I will divide by the coefficient of the variable, 375, on each side of the equation. When I do that, on the right-hand side, I'm left with a variable h with a coefficient of positive 1. On the right-hand side, I'm left with 6 2/3. So because this is a repeating decimal, we'll be very careful that we're going to keep it in a fraction form. It's more efficient, and we don't have to worry about the repeating part. So this is what we're looking for here, is the height. And so we would need to also make sure that we have our units. So 6 2/3 centimeters is the height of the water that's contained in this container.